Sure, you'll introduce yourself and
Yeah.
we'll learn about this.
Yeah, it's relatively easy. So my name is Michał Bilicki, and I'm responsible for the community work in LizardFS. Yeah. More volume. Does this work at all?
No, this is only
Okay.
recording.
Cool. I was wondering at the speaker before already that no audio. So my name is Michał Bilicki, and I'm basically managing the community activities of LizardFS. Right. We are a Polish project, and I'm today not introducing
Switch on the mic.
it. I think it's on.
Yeah, but the sound. I don't know. Looks good. Yeah.
Speaking very quietly. You have to speak really loudly. really loudly.
Hey, loudly. So today I'm not introducing LizardFS, but I want to tell you about what we did in the last 12 months, right? So if somebody doesn't know our project, we have a booth in Building K, plus there are people around here and running around the show with LizardFS t-shirts that can explain you every detail possible. Like one is sitting there, he actually wrote quite a lot of the stuff I will be talking about, so we have every answer available you could imagine. Right. Last year was last year was very important for us because we introduced many new features. We are a relatively small community, so being able to introduce all that in 1 year was quite a job. So we introduced NFS support via Ganesha. We introduced a new ACL support. We have full support of rich ACL. I will talk about that later more. We introduced a new task engine. We introduced support for HDFS emulation. And we introduced a new C client library that allows you to write your own LizardFS clients. We also started supporting read-ahead caching. We had some problems with sequential writes and performance, and that also vanished in the last year. We introduced support for massive recursive remove jobs. We created a whole new documentation, so at least most of the administration and installation features are pretty well documented. And we started supporting 2 new platforms, FreeBSD and Fedora. The FreeBSD one is still in the queue with the FreeBSD people. The port is published, but it takes its time in the FreeBSD community. We also did some changes. We have a Windows client, but we have extended the Windows support so that you can probably compile all of LizardFS now in the new Linux subsystem on Windows. It makes no difference if you like the platform or not, but one of the things we believe in is the more platforms you support, the more easy it is to find bugs. Right? Every compiler compiles differently, every platform shows you different bugs. For bug squelching, this is like the easiest way to see things that you wouldn't see if you just do it on one distro, one platform, one operating system. And we added some smaller changes, like people were complaining that you basically can have the situation where you have chunk servers running on the same IP address but on different ports, and your replication would be basically on the same machine, right? So we added a feature to recognize that. Our system now recognizes how much load which chunk server has and tries to adjust its writes to write to the lowest to the least loaded chunk server. We now have minimal goal configurations. We finally changed to a semantic versioning system, which was a bit confusing before, even for me. And we did a lot of small fixes that still to clean out still coding mistakes that come from the project where we forked off 4 years ago. We have a lot of places where small ports were not understandable in the code, and we seem to have reached the point where 90% of that is gone. We now have caching for faster directory lookups. There are new whole path lookup functions. If you want details on any of the more developer-like features, our main developer is sitting in this room and can answer any question you may have. We scratched quite some bugs. We had a lot of places where things were still set up for low speed networks and for low speed disks, and not prepared for the new, more performance hardware environments. Right, we fixed most of that. We had some problems with global locking, especially people that were using the Windows client had problems with that. We fixed that. We now support ARM officially. I mean, before it was very theoretically. Now we support it. There are still probably not all problems with ARM fixed because we don't have enough hardware for that, and are waiting for some promised hardware from people that want to use the ARM platform. But it seems to work because I know at least 2 customers that run their Lizard clusters on ARM. We also fixed some problems that we had with the mathematical library that we use, libjudy, that seems to be unsupported everywhere. So we had to implement some ways around the bugs. I think the Ubuntu one is totally borked. And I'm not sure if you found all the problems with it, but it seems that most of them are gone. Finding defective files was a bit complicated still last year. That's fixed as well. And request sizes in read cache have been fixed as well. They were often reported in 0 size, which was just wrong. Come on. Okay, so last year we introduced ACL support. The ACL support, the way the ACL support is presented depends on which platform your client is using, right? Because your client has to be able to present it. The backend system uses rich ACL, which is a superset of the NFS ACL, the NFS ACLs, and we try to translate in every client to the one that client is supporting. The only platform where we are not able, the only platform of the supported platforms where we are not able to do any translation or any ACL support is FreeBSD, because the Fuse library that we have to use there doesn't support ACLs. So for now, no ACLs for FreeBSD clients. Right? The documentation is being updated. I already have all the tables ready prepared, so you can see which platform gets translated how. And that should show up in the next 3-4 weeks in the documentation. You wanted to ask something for ACL?
For Windows, how do you do ID mapping from Unix IDs to Windows?
The question is how we map users basically in Windows. We have a Windows client that interfaces with the AD function in Windows itself. Right? It's not interfacing to the Unix backend. It's using the Windows own user and group interface. We have built a new task engine into Lizard. We used to have a lot of complaints about big jobs taking, basically nearly killing the metadata server. And we now introduced a task system that takes, for now, snapshotting and recursive remove operations and cuts them into small tasks, and in that way frees up the master server and prevents all this, all the locking scenarios. The task engine tries to first create as much a job as large a job as possible to get rid of as much of the job as you can, and then split the rest in smaller tasks. We have tested it, and basically we got rid of this problem completely. I mean, we haven't seen it happening anymore. It used to really be a big issue. What I see in the next year is that we will try to move that to other features as well. Right? It's not easy because the code base is quite big, and you have to rewrite every single client feature to be able to use that task engine. But for the two most complicated parts, which is snapshots, I mean, we had people that were waiting days for their snapshots removals to finish, and large recursive removal operations, that's completely gone. We also added functions where you can list running tasks, and you could also stop them. So if you think that your job will impact your metadata server, you're now able to kill every task that's running in the task engine. Yeah, we have options. The two commands that use the task engines are the commands for snapshots, make and remove snapshots, and the recursive remove command. And they got also a new option where you can tell them how large the first job should be, and if they should ignore any change that happens while the operation is running. I mean, they are both long-running operations, and if your snapshot doesn't ignore all changes that happen, then it probably doesn't make much sense. So you can choose now if you want the snapshot operation to care for changes that happened while snapshotting or not. Okay. Another feature that was added was read caching. We had some very primitive read caching till last year, and we noticed that it's not good enough to handle large sequential writes. The reason why we never saw that before was that we didn't have so many customers using Lizard for massively large files. I mean, Lizard is now used especially in genome setups where the file sizes get like incredibly large, and there you can see that there we have basically concrete numbers for how it behaves in sequential reads, and changing the read system to implement a more dynamic way of the read caching brought us, I don't know, when we tested with Roger, I think it was 8 to 10 times improvement into the performance. You can set within the mounts how large your read cache can grow. It will dynamically grow to that window size. You can adjust that per mount. So if you don't have any sequential reads, you can basically switch it off completely as well. Okay, we started, I think in January last year, we started a new documentation project. There's all of the installation, all of the self-compiling, and all administration commands are documented. Even some of the more complicated features are documented, like geo distribution, like setting up which chunk servers should be preferred for which clients. You can find all that. What is missing till now, and where we would be happy for any input if anybody wants to help, are the pieces about daily work with LizardFS. There is only so much we can write as the developers and the company that does support about your daily job. It would be far more interesting probably for users to get also cookbook-like or FAQ-like entries from normal users. Right? We are starting to document some of the more tricky management parts, and one of the things I'm currently concentrating on is to create more documentation for developers that want to join the project. So last year, after a long time of testing, I think 2 years now, we implemented Ganesha NFS as a, let's call it a translator from Lizard to NFS. It's implemented directly on the servers. So the Ganesha NFS server, metadata server, is attached directly to our metadata server, and every chunk server you want to take part in your NFS infrastructure is basically linked to its own Ganesha data server as well, which enables us to fully support NFS 3, 4, 4.1, and PNFS. We basically tried a lot of ways, starting with direct translation, which is always horrible. And for 2 years we tried to even implement our own NFS and use different platform NFS systems, and basically all of them more or less failed. You couldn't do HA, you couldn't support any parallelization, and with Ganesha we basically managed to have a fully integrated setup that translates directly without all the mount operations or fuse translations or whatever we needed before when we had to translate mounts. The implementation is relatively new. I think the release was in December. And as with the documentation, we are quite urgently looking for feedback and for testers to see how it behaves in different scenarios. One limit with that way of implementing NFS is that we only support it on Linux chunk servers. Right? Ganesha seems to use a lot of Linux-specific functions. So for people that use BSD or Mac or Solaris backends with LizardFS, we can support Ganesha there because there is no Ganesha on those platforms. The Ganesha project was also the main force behind finishing our new client library, which allows you to talk directly to your LizardFS backend, and I will talk about that later a bit more, but basically you now have a client library with which you can write in, probably in an hour, a client that replaces the mount command for LizardFS. So you could do all your file systems transactions for any application you want. No requirements for fuse, no requirements for any mounts. It's a direct client library to the LizardFS protocol. Another feature that we were asked for a lot, because people, when they read that you can support massive data structures, the first thing they start telling you is big data, was if we could offer an HDFS support. And we started working on that like 1.5 years ago without really understanding how Hadoop works. We are file system people. We are not really into data language and data analysis. So the first incarnation, let's call it, of our HDFS plugin was quite weird, and set on top of the mount system, and basically translated every command back and forth, and was totally unusable. Right. Then we decided to try the C API that comes with Hadoop. After managing to implement that, we had to find out that most of the features we wanted for the Java people that work with Hadoop are not implemented in the C API, and that most of our work made no sense whatsoever because we had an interface that was not usable. And it seems to be very complex to use it, and created overhead that was totally unnecessary because it was again Java to C, then from C API, then again to us. While working on that, Piotrek invented a library that I already mentioned in the Ganesha project that allows you to talk directly to the Lizard protocol. And once we created a direct connector that basically uses the API to talk directly to the backend, we started to be able to create something that has enough performance that we can now call it a Hadoop plugin. Right? It's still in the works, and we haven't published it yet because it was not really in an alpha stage till last month, but you should find it in the next couple of weeks on GitHub and can take a look. And again, there we are looking for feedback because we don't really have a large Hadoop cluster. It's all done on minimal stuff in our labs, and we don't really have any practical Hadoop experience. So we think it's feature complete, but we would very much like some people that have Hadoop to give us feedback if we are right, because it's mostly guesswork right now. What was interesting was that there were a lot of problems with Hadoop itself, because different things were differently implemented in different parts of Hadoop. So, for example, we had an interesting experience that with the message file not found exception is not an instance of file not found exception, because it's differently implemented in MapReduce and differently in Hadoop. And devs spent like weeks on finding where the bug is until we found out that it has nothing to do with us. It's on the layer up in Hadoop itself. So this was quite an interesting experience of trying to link with a different project where you have actually not much idea of. So currently we have, according to the HDFS tests, we have a feature complete HDFS on top of LizardFS, speaking directly to the backends. There is a small installation documentation already done. What we are adding now is how to use it. It should show up in the next couple of weeks in GitHub. We are looking for help with quality checks for it, because like I said, we have a very, very small Hadoop cluster, and there's only so much we can try there because we have no practical experience. So any feedback from the real world would be very appreciated. So while we were working on Ganesha and NFS, we created a library that we have published in December with a 3.12.0 release that you can use to write native Lizard clients. Right, there is, it's available on all platforms that we support. Documentation is in the works. What is available now is an example file that shows you how to import, how to include it into your own projects. It's pretty easy to use. It includes features for logs, for writing, reading, unlinking, opening and copying objects. It allows you to get information about the state of each chunk server or all the chunk servers, so you could make use of the feature that checks for loads on different chunk servers, for example, and it allows you to manage ACLs. The example file is, I think, 1K big, so it's pretty simple. And if you have any questions with that, the author is sitting here. So. Yes. So much about what we did in the last 12 months. I want to give a little insight of what we have planned for the next year or probably even longer. We are releasing today the source code for our HA engine for the metadata servers. That used to be a commercial add-on from Sky Technologies. We are releasing the Hadoop plugin, as I said, to the public because we think it's so that it's showable. And we are starting to work on something we call Agama, which is the next generation of Lizard, which has a lot of internal changes. So I have some more to say about that in about 2 minutes. We have extended our testing to the Windows subsystem for Linux. We found out that we can really put that we can translate all of LizardFS to it. The only thing you can't do on the Windows subsystem is work with signals, because there are none. It's pretty interesting as the next testing platform. So, the new LizardFS has a whole different internal architecture that's mostly focused on performance. We think everything in the normal features is stable, and we are now moving to get Lizard to a different performance level. We want to start with a completely new client, and then move the changes that we put into the client also into the metadata and the chunk servers. The client will be totally backwards compatible, so basically you can start working with the client and then upscale the rest as well. The changes are that we have planned is we are moving from the single monolithic setup how we have it now to an event-driven architecture. We are switching to async I/O. Utilizing the ThinkAsync library because we think it's the easiest way to stay current also with the C++ standards. We are trying to get rid of a lot of pieces that use in-kernel features, especially looking at the bugs that show up all the time in the kernel space. We would like to get out of there as much as possible. So all our network features are, for example, now 100% in user space. We are adding a new tracing subsystem to all the modules, because for now you just get massive log output from the chunk servers, from the metadata servers, from the loggers, from the clients, and it's relatively hard to correlate which piece is related to which function on which component. So now there are 64-bit identifiers on every transaction that is being logged, so you can see and trace in your distributed system where your things go and why and when. There's a new monitoring feature being introduced that will allow us to automatically adjust timeouts, to automatically adjust settings, because we had a lot of situations where customers don't use the easy set like we tell them, but go into relatively complicated parts and just fiddle around and then come back and ask for support with a fiddled setup. Yes?
What's the source of truth for the transaction identifiers?
The source?
Yeah.
What's the source for the transaction identifiers?
Who assigns those items?
I don't know. So I have the developer who wrote that here. We can answer the question afterwards. I get him here to answer your question. Okay. So we added a new we are adding a new monitoring system that is basically set, like I said, to automate all the settings where people were telling us that they are encrypted, not understandable, and create a lot of support overhead because people just set them and then call and write and say it's not working. We haven't changed anything besides this 70 settings. Yeah. So stuff that is relatively fixed now and work has started on it is the client. We have eliminated most of the kernel caches. We have started on implementing the client so that it uses a user space network subsystem. Right. There is now full write versioning in the works. Till now, the system was doing partial write versioning. We found we saw that this leads to relatively slow writes because only one chunk server at a time can write to the backend. If you have full write versioning, basically every chunk server that wants to write into that place can do that, and the newest version basically wins. That allows to improve the I/O by a factor of up to 100. It also safeguards you against some edge cases in erasure coding, where basically parity could be written twice and destroy your stripe set. It also helps you against some very rare edge cases where microseconds of differences occur in writing to different metadata servers. If you have full write versioning, the synchronization is much safer and basically easier to handle. Yeah, and as I said, the writes become much faster now. I mean, in tests we were able to saturate a 40G interface now. Yeah, with one client. So the things for the chunk servers and the metadata servers are basically planned. I mean, currently we are working on the client, and the idea is to move all that we find in the client to the backend servers as well. And the plans for the chunk servers are relatively easy. I mean, we will take the same AIO work for event-driven architecture and asynchronous I/O, take the user space network functions and move them to the chunk servers as well. And there's a lot of work planned to get rid of old complicated structures and simplify the whole thing. Reason is, one of the main drivers of the project is simplicity. I don't know how many of you have used LizardFS, but normally a setup takes I don't know, I can set up a very basic LizardFS in about 20 minutes. Right, complete, with prepared for simple erasure coding even. So we want to make that even simpler and automate as much as possible and get rid of a lot of stuff that we still find too complicated. Same is planned for the new metadata server. The metadata server additionally will have this this monitoring feature I said something about before, that will allow you to move a lot of the more complex settings to be automated. So timeouts, backend drive handling, interactions with the backend file system, read-ahead cache settings, and so on will be automatically will be possible to be set automatically by the metadata server on the chunk servers and even on the client. The other feature we want to introduce that was asked a lot is a distributed network of metadata servers. We are currently experimenting with different key value stores to be able to create a network of active metadata servers. But that's all more at the planning stage than anything else, because concentration currently is on the clients. So also the right versioning that we are currently implementing in the client will take its way to the metadata servers as well. So we are today open sourcing the HA backend that we have developed for LizardFS. It's called UREFT. We are using it since 4 years successfully at all our commercial customers. It's based on the REFT algorithm. It is a quorum-based backend that switches IP. It requires at least 2 nodes plus a quorum node or 3 nodes. The settings are really easy. I will show an example. The switchover times that we have are in the sub-second range, and you can use it. You can use it probably for whatever you want, but our scripts that we will publish are for our metadata servers and for the Ganesha meta servers as well. It uses a floating IP model. It has a very fast election process. You can see the theory behind it on the REFT algorithm definition page, which basically has a very nice graph about how the election process works. The resources it uses are absolutely minimal. Very often we put the quorum node on the same box as the chunk server, and you don't even notice that there is a change in resources on the box. So this is an example of a UREFT configuration. You start with describing which node has which address. You add the floating IP and the floating netmask and the interface that you want your IPs being switched on. And the only difference between your nodes is in the UREFT ID. Right? The configuration is the same on each node. You just give each node a different ID, and that's your whole setup. So it's really simple. Yeah, and my time is up.
Yeah. Sorry. Yeah, time is unfortunately over. If you have more questions to LizardFS, visit the booth in Building K. Yes. Thank you.
Thank you.